Welcome to the first episode in the Cyclone DX Learning Series. In the next few minutes, we'll explore Software Bill of Materials, or SBOMs, the Cyclone DX SBOM standard, its origins, and its design philosophy. Be sure to like and subscribe, and you'll get notified of new episodes that could help you and your organization get the most from Cyclone DX. Ready? Let's dive in. Bill of materials, or BOMs, have been commonplace in many supply chains for decades. Now, when you purchase an automobile, the latest consumer electronics device, or pharmaceutical, the manufacturers of those products have a list of ingredients and the suppliers that they obtain them from. Now, with this information, they can control cost, increase quality, and respond to defects that might impact public safety. Bill of materials are nothing new, but they are relatively new in the software industry. Many individuals within government and the information security industry have been advocating for software bill of materials for years. Then, in 2017, there was some ongoing work in the global OWASP community that led to researching the existence of bill of material formats that could be used for cybersecurity use cases. The only standard that existed was SPDX, which had done some really great work in the licensing space, especially around standardizing open source license identifiers. However, the SPDX specification didn't meet OWASP requirements for software security use cases. As a result, Cyclone DX was born. Cyclone DX is a flagship OWASP standard that's designed by security professionals for cybersecurity use cases. Now, with the recent executive order in the US requiring SBOMs, along with similar efforts around the world, Cyclone DX is uniquely positioned to allow organizations to quickly adopt SBOMs that meet these government requirements and mature their cybersecurity use of SBOMs to achieve greater and more in-depth intelligence about the software in their supply chain. With Cyclone DX, you and your organization can make better risk-based decisions. The Cyclone DX project has many guiding principles that truly make it unique, and it starts with a risk-based approach to standards development. Rather than spending years creating a standard, Cyclone DX delivers early and often, providing the community immutable and backward compatible releases that provide immediate value. Now, historically, the project releases an updated version of the spec on a yearly basis. Another guiding principle was automation. Cyclone DX had to be highly automatable. Creating a single SBOM is relatively easy, but the spec needed to be automatable across really large and complex processes, and it had to scale to producing tens of thousands of SBOMs per day or more across an organization. So, the Cyclone DX data model had to be extremely efficient. And with all this automation happening, the spec needed to minimize the possibility for implementations to misinterpret the spec, which obviously could lead to erroneous or invalid SBOMs. Interestingly, the prescriptive nature of the spec also makes it really easy to adopt. It's simple for organizations to go from producing SBOMs in one or two builds to producing them across their entire organization. There's tens of thousands of organizations doing this today. And if you're interested in creating your own tools that support the standard, it's just as easy. Whether you're a single open source contributor or a large commercial vendor, reading, understanding, and implementing the Cyclone DX specification is really simple. And there's reference implementations and examples to help you along the way. Ease of adoption is critical to the success of any standard, and this is especially important with Cyclone DX. While much of the SBOM work has been focused on producing them when software is created, SBOMs can also be created by monitoring systems at runtime, by SCA tools, or via different forms of forensic or binary analysis. There's just so many different ways to arrive at SBOM that it was really important to provide an easy path to adoption. And finally, it had to build upon existing specs where applicable. So SPDX license IDs and expressions were absolutely incorporated. Support for existing identifiers such as CPE, package URL, and SWID were also incorporated. And support for digital signatures, including XML signature, JSON signature format, and JSON web signature were also supported. Existing serialization formats were leveraged. The spec supports XML and JSON, which are ideal for sharing with others in the supply chain. And the spec supports protocol buffers for highly efficient machine-to-machine use cases. In all cases, SBOM validation leverages existing standards, including XML schema and JSON schema, allowing tremendous flexibility and exceptionally fast, accurate, and efficient validation. Two great resources to get started is the CycloneDX use cases and examples. As the name implies, this section of the website provides a number of use cases along with examples in both XML and JSON. The other resource is the CycloneDX Tool Center, which is a community effort to establish a marketplace of free, open source, and proprietary tools that support the CycloneDX standard. Links to both resources are in the description below. The CycloneDX project has a large and engaging community of adopters and implementers. Links to the Slack workspace are also below. So that's the background about CycloneDX. If you found this video useful, please be sure to like and subscribe, and you'll get notified of new episodes that could help you and your organization get the most from CycloneDX.